And when you actually have a job and you're working in something that you're passionate about, it's not work, it's fun, all right? And the other side of that is, if you're passionate about it and it's fun, you're going to excel at it. We look for folks that have excelled in their field to be selected to be an astronaut. My passion, ever since I was 5 years old, all I wanted to do was fly airplanes. And I remember taking a trip to the Air and Space, well, it wasn't the Air and Space Museum then, it was the Smithsonian Museum in Washington, D.C. And I saw the Spirit of St. Louis and the Wright Flyer hanging from the ceiling. And it captured my imagination as a young boy. And I read all the books I could about flying. And I said, I want to be a pilot. Next slide. The Wright Flyer, also hanging from the ceiling. All right? You know, and when you think about it, and I'm going to digress a little bit here. It was December 17th, 1903, when Orville and Wilbur flew the first powered flight of an aircraft at Kitty Hawk. How many have read the biography, the book about flight? Man, you guys want to be pilots in your Navy? Come on, man. So it's a great story about how they accomplished what they did and what it led to, all right? But the first flight, it traveled a distance of 120 feet and it only lasted 20 seconds, okay? So aviation was kind of on that flat part of the curve for a long time before it took off exponentially. When you look at the aircraft that we're flying today, like the F-35, it's amazing. Well, space, we're still back on that flat part of the curve. Next slide. So those first astronauts, you know, let's put things in perspective a little bit. And I'm gonna talk about the different astronaut classes. With that first class, the Mercury 7, what do you notice about them? They were all white men, military test pilots, right? And that was in May of 1961. Alan Shepard went up, parabolic arc, 15 minutes in space, came down in the Atlantic Ocean. Next slide. That's John Glenn. That was February of 1962. Yuri Gagarin flew the first flight April 12, 1961, orbited the Earth, right? We didn't orbit the Earth until John Glenn in February of 62. Now, I like to say, truthfully, Yuri Gagarin, although he orbited the Earth, he didn't actually land in his capsule. He got ejected out of it and came down in a parachute. And that shouldn't really count because John had to. Next slide. Rockets got bigger. We selected more astronauts, the next group. And we were flying the Gemini program on that Titan rocket, right? And we learned everything we needed to know on the Gemini program in order to go to the moon. Next slide. Rockets got bigger. The Saturn V. We went to the moon with Apollo. What happened at the end of the Apollo program? They picked astronauts. They weren't test pilots. They were scientists. But what else? They were still white men, right? All right. Next slide. We went to the moon. Next slide. we did Skylab. Next slide. And then April 12th, 1981. 20 years to the day that Yuri Gagarin flew, we flew the gutsiest test flight ever with two naval aviators, John Young and Bob Cabanna, and we flew the first flight of the shuttle. And when people ask me, what was the most amazing contribution of the shuttle program, right? I tell them, the shuttle brought diversity to America's space program. We went from all men, all white men, and military test pilots mostly, with a few scientists thrown in at the end, to a very diverse group in 1978. Those 35 new guys had men, women, black, white, Hispanic, Asian. The shuttle accommodated from the 5th percentile female to the 95th percentile male. We opened up space to everyone. Next slide. We did science missions in space. Next slide. The space labs that were processed here at KSC, they're flown in space. That was my third flight. I got to command INL-2. It was just like being on the laboratory in the space station today. We did science 24 hours around the clock. Half the crew worked while half the crew was off. Had 83 experiments from around the world. We deployed the Hubble Space Telescope. We built the International Space Station. Next slide. We went to the Mir Space Station. Next slide. No, that's Mir. Next slide. That's the shuttle docked to Mir. That's Atlantis, as a matter of fact. on SDS-71. Who gives him command of that mission? Next slide. I like to think this is kind of a historic flight. This is December 1998, and that's Endeavour. Next slide. And we took up, next slide, we took up the first pieces of the space station. That's what the space station looked like after we laid the cornerstone and activated it. Next slide. That's what the space station looks like today. And that's what we're supporting right now with U.S. astronauts, all right? It's getting to the International Space Station. Next slide. One more. I'll back up. So, this is what the node looked like when I was in it. You know, now remember, I was a colonel in the United States Marine Corps, ship shape. Look how clean and neat it is. Next slide. That's what it looks like today. Now, that's Salazar Sharapov inside Node 1 on the space station. That's where the exercise equipment is, the advanced resistive exercise device. The crew gathers there. That's where the airlock is. That's where the cupola is with all the great views of the Earth that you see. Next slide. And that's, remember what that shuttle looked like docked with mirror? That's what it looks like docked to the space station. Next slide. So how do you get up there? All right. As I said, that first group of shuttle astronauts opened up space to everyone. Next slide. So these are the astronaut selections. You know, if you look at them, again, I point out that first group, and it talks about what the requirements are. You know, Bachelor of Science degree, a lot of flying time, test flight experience. And you run through all that. Next slide. So, bottom line is, over time, we have selected, you can't read it, it's blurry. It's not your glasses, trust me. I got 20 minutes? 330 U.S. astronauts, all right? But, let's look at, where's that 78 group? 1978. You know, they had 8,000 applicants. This last class, if you look down here, 2017, 18,400 applicants, and they picked 12. How do you make it through that kind of selection? You know, I'm so glad I got picked when I did. I tried here and didn't make it, and I made it here. But, you know, 1,400, 4,900 rather, and you got 30 out of that group. That's a lot better odds than that down there. First off, you're not competing against 18,000 people, all right? You're competing within your field. And I said, I'm so glad I got picked when I did, because to me it seems much harder now. But if I were competing today, I would compete in the category of flight test, all right? And it's broken down, you know, general engineering is the hardest, because that's where most of the applicants are. But there's life science, earth science, space science, you know, flight tests. So you're competing against people that have a background similar to yours. Next slide. So then 2017 class by the number, 18,000, and they got it down to about 12,000 that were qualified. That 12,000, they necked down to 440 highly qualified. And from that, they picked 12, right? How do you make it through that process? Next slide. They had interviews, all right? They actually necked that all those highly qualified, those 400 highly qualified, down to about 120 that they interviewed for a week at the Johnson Space Center in Houston. And they invited them in 20 at a time. So they had 6 weeks, 20 at a time, and they put them all through these interviews. They did tests with them. Something that, tests that I didn't have to do when I went there. They're looking at, you know, how you behave in a group, how you handle, you know, the psychological testing is different than I did. But the main thing is, they're looking at skills tests also, how they perform different skills. They put them in a different environment and just see how they do. From that 120, they necked it down to 50 that they brought back for a second week of interviews to select the 12 that they did. Next slide. So what are the basic qualifications this year? What are they doing different this year than they have in the past? First off, they don't select mission specialists and pilot astronauts anymore. They just select astronauts. pilots, all right? Everybody is just called an astronaut. There aren't mission specialists or pilots anymore. The other thing that they've changed is you have to have basic qualification, right? In order to apply, it used to be you could have a bachelor's degree with 3 years of experience in your field. And you could substitute a PhD for 2 years and a master's degree for a year. So if you had your PhD, you were qualified. Well, today the minimum qualification is a master's degree. You got to have at least a master's degree in order to apply. And test pilot school counts as a master's degree. For the folks that went to test pilot school, they didn't have a master's degree. And then you got to have a minimum of 2 years of experience in your field. If you just meet the basic qualifications, you're probably not going to be competitive. All right? So, what is it? What do we look for? How do you become competitive? How do you make that happen? Next slide. Well, that's that first group back in 1978. And I'm going to come back to a lot of this. To be competitive, it's what separates you from everybody else. What do we look for in somebody that we're going to select to be an astronaut? I've been on screening panels. I sat on a number of astronaut selection boards when I was chief of the astronaut office and director of flight crew ops. And we look for folks who are team players, all right? It's not about me, it's about the team. And, you know, it's amazing. You can look at people on paper and you can say this person is so qualified. And when they sit down in front of that interview board, it's like, wow, how did we ever select this person for an interview? You know, it's pretty amazing what some folks have to say. But the key is, you want to be a team player. You want to be a good communicator. All right. You want folks to get along with other people. Because, you know, a mission to Mars today, right? You're talking a year and a half to 2 years. You don't want to be stuck up there with some jerk, you know, for that long period of time. You want to have people that you can get along with. And we look for people that excel at what they do. But then, what's that X factor? What separates you from everybody else? And I'm going to come back to more of that and I'll take questions. But once you get selected, you know, a lot of people apply for being an astronaut and they don't even know what astronauts do. They just think, well, that sounds cool. I think I want to be an astronaut. So I want to talk a little bit about what it is to be an astronaut. Most of what astronauts do is not fly in space. They do what you do. They do what I do on a daily basis. We support other people flying in space, all right? Astronauts work in mission control, CAPCOMs, capsule communicators. They test software. They help design new spacecraft. All the jobs that you're doing right now, those are the jobs that astronauts do most of the time. And then every now and then you get assigned to a flight, and you train for that specific flight, and you get to fly in space, and then you come back and you start supporting other people flying in space. So it goes back to, how do you get to be an astronaut? First off, I hope that you're passionate about what you're doing. It goes back to me. My passion was flying, right? That's all I ever wanted to do, and I pursued my passion. So remember that. Next slide. That's the shuttle mission simulator, the motion simulator in Houston. It is no more, all right? It's gone. How many have ridden the shuttle launch experience at the visitors complex? That is better than that simulator as far as what it feels like to fly. The only way, and it doesn't last a full 8.5 minutes either. The only way I can make that simulation better at the visitor center is if I can sit on your chest while you're riding it, and that would feel, because that's, man, you are just pushed back in your seat. It's this sense of speed and acceleration, and all those pops and crackles you heard when you were watching it, you know, at KSC when it took off. You hear those in the cockpit too, but then there's this sense of just, it's just, it gets up and goes. When, so the orbiter had a 3G limit on it, 3G acceleration limit. That was the structural limit on the wings. So at max dynamic pressure, the engines actually throttled back to keep from exceeding that 3G acceleration limit. And you didn't really feel them throttle back, but when they throttled from 72 up to 104%, it was like, whoa, and you feel like you're pushed back in your seat even more. The solids burn for 2.5 minutes, or 2 minutes and 5 seconds rather. And when they separated, the thrust would tail off a little bit, it felt like you were slowing down, but you just weren't accelerating as fast. And then there was this huge bang and flash in the forward windows as the set motors pushed the solids away. And then it was like electric drive on those three main engines. It was just a smooth, quiet, steady acceleration. And then 7.5 minutes prior to main engine, 7.5 minutes, a minute prior to main engine cutoff, you hit that 3G acceleration limit, and you're being pushed back in your seat. And then at 8.5 minutes, the engine's shut off. And you come forward in your seat, come forward in the straps. It feels like you stopped. You just stopped accelerating. You're going 17,500 miles an hour. At that point, you're about 65 miles above the earth. You continue to coast out to your apogee, depending on what your orbit is, maybe 160 to 220 nautical miles. Then you burn the Ohms engines to circularize your orbit. Just a heck of a ride. So we trained for that in that simulator. It doesn't do it justice. You know, how many you've been to Atlantis? You probably looked in that mock-up that they have. Not a very high fidelity mock-up, but you get an idea for it. What you really have to do if you go in there, remember, first off, we had to raise it up so that people wouldn't bump their heads on the switches. So it's not that tall in the real orbit. And then it's split apart, right? So you got to bring it together. But then if you bring it together, you notice the panels are duplicated on both sides. So you'd have to take out one set of panels and then bring it together. And this is what you'd end up with. And the first time I looked in there, I said, how am I going to learn all those knobs and dials and gauges and switches? It's like anything else. We spent a long time training, but you learn one system at a time, then you learn the nominal, then the off-nominal procedures for it. Eventually you learn all the systems, and you bring it all together. Next slide. Spacewalks. You know, the first time you do a spacewalk, you're prepared for it, right? Next slide. This is NASA's microgravity research aircraft, and what you do is you go over the Gulf of Mexico, you climb up to 30,000 feet, and you're flying along in level 1G flight. You do a 2G pull-up to your 45 degrees nose high, and then you push over in a parabolic arc until you're 45 degrees nose low. And for about 30 seconds at the top of that parabola, if you push just right, you've got 0G, right? If you push too hard, you're pushing people on the ceiling. If you don't push enough, you're still bouncing on the floor. But if you do that parabola just perfect, you got 30 seconds of weightlessness. And then it's 1G, and then a 2G pull-up. And they'll do about 30 of those out over the Gulf, right? So 1G, 2G, 0G, 1G, 2G, back and forth like that 30 times. In Houston, it's affectionately known as the Vomit Comet. Next slide. Didn't you get a laugh? Anyway, so this is one of the classes with their first indoctrination of what it's like to be weightless. Next slide. We actually qualify experiments a lot of times before they fly in space on zero-G aircraft. Next slide. You cannot get into a spacesuit in 30 seconds. Next slide. And you can't do everything you're going to do on a spacewalk in 30 seconds, 30-second intervals, all right? So, next slide. We have a facility at the Johnson Space Center. It's called the Neutral Buoyancy Lab. It's this huge swimming pool that has a full-size scale model of the space station in it. Next slide. We put astronauts into those EVA suits. Next slide. And lower them down in the pool. Next slide. And then they get weighted out so they're neutrally buoyant. They don't sink to the bottom or float to the surface, all right? They'll practice everything they're going to do on a spacewalk in that pool. It's not what it's like to really be weightless, but it's the best that we can do for a simulation here on Earth. Now, it used to be, if you take like a Hubble Space Telescope mission, where it's very defined what they have to do, for every hour spacewalking on a Hubble mission, they spend 10 hours in the pool in training. So a 5-hour spacewalk meant 50 hours in the pool. All right. Today we have less mission-specific training because the astronauts have to be able to prepare anything that breaks on the space station, right? So we do skills-based training, and we've gotten it down from 10 hours where now it's about 7 hours. So if somebody does a 6-hour spacewalk, they probably spend about 42 hours in the pool getting ready for it. And crews do multiple spacewalks, so that's a lot of time down in the pool. You even see the robotic arm. They have an arm that's actually in the pool with an arm operator and an arm station. It's just like being inside the space station, operating it, controlling the astronaut down in the pool. Next slide. And you get some idea of the size of the space station. You know, that's the truss structure down in the pool, and you can see the size of an astronaut on that. I used to do scuba when my crew was training for the spacewalks on the space station assembly mission. If I wasn't flying the arm, I'd get scuba gear on it. I'd go in and watch them down there. And it was so cool just swimming around inside all that truss structure and stuff. Next slide. For those of us who are pilots, we had T-38s to maintain our flight proficiency, but also, you notice there's somebody in the back seat. A lot of the folks that weren't pilots have never been in a high-performance jet aircraft or operated in that environment. And things that you do in a jet are so much different from a simulator. You have to make real-time decisions that impact, you know, your safety, all right? And so the T-38s, in addition to maintaining flight proficiency for the pilots, it's also a great tool for teaching crew coordination and working together as a team. Next slide. Actually, they've been modified since this. This is one modification. Now we've gotten rid of most of the old steam gauges, and it's all glass now. Next slide. The first time you land the shuttle is the first time you ever land the shuttle. Next slide. You can practice that steam elevator.